All right, so we're going to get started with exercise 211. And actually, for the next 3 classes, 211, 212, and 213, we're going to be dealing pretty extensively with topography. I will also be very repetitive in terms of the steps. What will end up happening, though, is I will go through, like today, we're going to go through a kind of an overview. And then next class, I'll start from the beginning and do the stuff that I do today and then add on to it. And then on the third day, I'll start from the beginning and go all the way through. So you'll see it as a progression. And I'll speed up how fast I go through it as it goes along. This set of exercises has kind of 2 components to it, or 2 reasons behind why it's important. Number 1, I want you guys to work with non-orthogonal, complex surfaces. So terrain or topography is a great example of a very complicated surface. It's going to move in all directions at once. It's going to curve in all directions at once. And so working through that is a big advantage once you really understand how it works and how to work from it. Number 2, we're going to come from SketchUp into Rhino. This will also talk to you a little bit about how you work from SketchUp into Rhino and back, etc. Well, hopefully it's never back. But how can you bring an object in? There are, of course, other commands that will help you do this. I'm going to concentrate extensively today on the curve network command or the network surface command, which we've already used. This is just in a little bit more complicated context. Next class, you will get your handout for your next assignment. Don't forget, by the way, that your assignment 201 is due on Monday. So you'll turn that in, and then you'll get your next assignment, which is 202. The other advantage is that 202, the assignment 202, is basically what we're doing in lab next week. So between 212 and 213, you should be able to get through most, if not all, of assignment 202, other than building the model and the topography itself. As part of assignment 202, you will be constructing something physical. You'll be handing in an actual model of topography. I'm going to teach you how to go about creating that. And so we'll talk about that down the road, because it doesn't matter for today's purposes. Today we're going to concentrate on working from SketchUp and bringing that into Rhino, and then working and manipulating that surface in Rhino. So as much as it pains me to say this, I'm going to start by opening SketchUp today instead of Rhino. And there is online on our website, if we go to today's exercise, wrong semester, there's a sample file, a Hawaii terrain sample file. If for some reason your file isn't working from SketchUp, you're more than welcome to use the sample SketchUp file. If not, you can create a new or pick a new location. When it comes to today, you can pick any location you want. Next class, when we're working with the assignment, picking something with reasonable hills is a good strategy. So don't pick Half Dome at Yosemite where it's a cliff. Pick something with some reasonable hill to it. It's nice when you have some hill. If it's too steep, your model's going to be really hard to make. If it's too flat, it's not going to be very interesting. So we want some in the middle. For today's purposes, you can pick whatever you want. It doesn't matter. I'm going to go ahead and in the template section here, I'm going to pick the architectural design feet and inches. It doesn't really matter if you're in the simple template. And I'll click on Start Using SketchUp. And that will open up SketchUp. I'm going to delete the little person here. We don't need that person. And then I'm going to go to the File menu, and I'm going to go to the Geolocation menu, and I'm going to choose Add Location. By the way, this is a feature that is only available now in SketchUp Pro. So if you have regular SketchUp on your computer, not the Pro version, this part won't work. Yeah. It's under File, Geolocation, Add Location. And so a couple things. One, if we were working with a real site, like if we were doing an architectural design in a particular location, there would be some terrain. You would probably have a surveyor come out, and they would actually say what our contours were, and we'd build our model from that information. We don't have that right now, so we're just going to pick a location and use Google's interpretation of terrain, which is not the most accurate in the world, but it gives us some place to start. And so really what you're picking is entirely up to you. We could pick something on Mount Diablo, for example. We could zoom in here, if I can find it. Yeah, it should be in here somewhere. There we go, Mount Diablo. We can zoom in here. At some point, as you start to scroll in, you'll get a white square. That white square is the maximum amount of terrain data that SketchUp will let you take. As you zoom in, that white square starts to disappear, and then eventually you could take the whole screen. I would get to a place where you're seeing this white square like this and take this amount of data. Once I have it, I can click on the Select Region button. I can adjust that to get the full region. You see that it's maxing out. I can't get any more than that piece of information. And then I can click the Grab button here. And when I click that Grab button, it's going to bring in the terrain like this. It's not going to look like much yet, but we can take a preview of it by going to the File menu and again going to the Geolocation menu and clicking on Show Terrain. So that's File, Geolocation, Show Terrain. And then I can orbit around. I'm using the middle mouse to orbit. It's a little bit different than our standard right-click to orbit. And I can take a look at my terrain. OK, that seems like a reasonable piece of terrain to work with. I'm happy with it. So at this point, I'm going to go ahead and export this SketchUp file. And I'll do that by going to File and then Save As. It's important to go to File Save As, not File Save, because we need to go back a few versions of SketchUp. I believe SketchUp 2013 will work. I think on the handout I say SketchUp version 7. I think Rhino's been updated enough to get to 2013's version of SketchUp. If you pick one of the newer versions, chances are Rhino's just going to throw you an error when it comes in. It doesn't matter. The accuracy of the information coming in is just fine. So I'm going to go to SketchUp 2013. I'll go to my flash drive into today's folder here. And so this is Mount Diablo. And I'll go ahead and click on Save. So once again, it's SketchUp version 2013. So the good news is that's all I have to do in SketchUp. I just got my piece of terrain, and now we can move on into the world of Rhino. So I'm going to go ahead and double-click to open up Rhino here. I'm going to choose my large object inches template. I hope. Excellent. And once I'm in Rhino here, I need to bring in that SketchUp pile. I'm not going to use a block reference because I'm going to manipulate this actual surface. I want to bring it all the way in. So I'm just going to go to the File menu and choose Import. And when I do that, I have to go find my SketchUp file. So I had saved this into today's folder. There it is. When it's all compatible file types, you'll see it listed as the SketchUp file. I'll go ahead and click on Open. And then I get the SketchUp import options. So we're going to bring the SketchUp in as a mesh. We haven't worked with a mesh just yet, and I'll show you what that is in just a second. The rest of the default options are just fine, and I'll go ahead and say OK. It is important to note that my Rhino default units are inches. My SketchUp default units are inches. I want to make sure those two match. So if you have your SketchUp file in inches and you have your Rhino file in millimeters, we're going to have issues. So make sure that it's inches to inches as we bring across. So if I double-click on the perspective view here to make it large and I zoom out, I'm going to see a version of that terrain. It's the same version of what I'm seeing here. So let me go ahead and view it as a shaded object. And a couple things. SketchUp brings in the triangulated mesh, which we'll talk about in a second, but it also brings in this flat plane, which is extra data from SketchUp. For our purposes today, it doesn't matter. I'm going to take this and put it on a layer for SketchUp. Go ahead and create a layer called SketchUp. And I'll create a sublayer for plane. I'll change this onto that layer, change object layer. There we go. I'll create a sublayer for terrain. And we'll put this, let me call this mesh instead. I think it'll be more clear. I'll right-click, change object layer. Now it's on the mesh layer. So I've clarified my drawing a little bit by changing my layers. And that also means that I can get rid of a bunch of these other layers that don't matter. So I'll select them all. I held down, click the first one, held down Shift, click the last one. I'm going to press the Delete key. And there we go. I left my default layer, and I'm going to turn on my mesh layer. There it is. So the SketchUp file that comes in is something called a triangulated mesh. And what that is it's a bunch of triangles that are connected together that approximate this piece of terrain. And so as I zoom in here, if I look at a ridge, so right there, you can see that there's these weird kind of funny depressions going up the ridge because of the triangulated surface. The denser the triangulated surface, the more accurate the surface would be, but it's still made up of facets. It's always going to be faceted, as opposed to being a nice, smooth surface. So what I want to be able to do here is I want to be able to convert this into a nice, smooth surface. And I want some control over how I do it. So what I'm going to do is I'm going to slice up this surface in multiple directions. And essentially, I'm working toward building a curved network. And so I'll slice this mesh up using contours in the x direction and contours in the y direction. For clarity purposes, I'm going to orbit around so that I'm facing in my x direction here and my y direction there. I'm looking at my little, what would this be called? Axes down here at the bottom, so that I can kind of orient myself. Does it really matter whether you're in the x or the y or not? No, but I just want to be going in two different directions. Remember when we did curved networks, we distinctly wanted curves going in one direction and curves going in the other direction. So using the axes to help doesn't hurt. So I'm going to go ahead and create a brand new layer. I'm going to call this layer Contour X. I'm going to create another layer at the same time called Contour Y. So I have a Contour X and a Contour Y layer. I'll make the Contour X layer the default layer, so I'll double click, move my check mark down, so the objects I create are going to end up on the Contour X layer. So at this point, it's time to actually create the contours. So I'll go up to Curve, Curve from Objects, Contour. Alternatively, I could type in Contour. And what a contour does is it essentially takes a surface and slices it up into a parallel number of lines. And so it says select objects for contours. I'm going to pick this mesh surface here. I'll press enter when I'm done. Then it's going to say contour base point. That would be this corner right here. I told you I was going to start at that point. Now, I can't snap to it because I don't have my object snap on. But even if I turned on end, mid, and perpendicular, my standard snaps, it still wouldn't snap to it because it's not a standard object. It's a mesh. So I'm going to go all the way down here and I'm going to choose vertex at the end. Because it's a mesh, that will then let me snap to it. I'll zoom in and I'll pick right on the corner there. And it's going to ask me direction perpendicular to the contour lines. So this doesn't really matter, other than we want to make sure that we're going perfectly out along the axis. So I'm going to turn on ortho. I'm going to make sure I'm not snapping to anything. I don't want to snap to this point up here. I just want to come way out in space. I'm not snapping to anything. It's just going off into space along the x-axis. I'll go ahead and click. Next thing it asks is the distance between the contours. So this is a little bit of a guess. And so I'm going to guess at 100 feet to start. So I'm going to type in 100 feet, and I'll press enter. And when I do that, it's going to slice up my surface into a series of parallel lines. I could turn off my Google Mesh there, and you can see that, yes, it's a bunch of parallel lines. The places where people go wrong in this is when they do the contour, they don't go directly out the x-axis. They go up on an angle, and they get a bunch of diagonal contours rather than straight up and down. You can confirm that they were done correctly by looking in the side view or in the front view, and all of those lines should be perfectly vertical. So I've done that. Let me turn back on my mesh. Before I move on, I'm going to make sure that nothing is selected. And this is another place where people get messed up. I will change to my Contour Y layer. There we go. And I'm going to use the contour command again. So it's curve, curve from objects, contour. Select objects for the contour. It would be here. I'll press enter. Contour base point would be right there. I'm going to go, sorry, never mind. Should have been over here. So contour, no. There. Base point would be there. Sorry, I want to be on the same. And this time I'm going to go out in the y direction. Again, I'm not snapping to anything. I'm going right out there in the y direction. Distance between the contours, I'll use the same 100 feet, and I'll press enter. And that gets me a set of curves going in the opposite direction. So if I turned off my mesh there, we'd see the contours going in both directions, essentially representing that surface that it just came from. So where people screw up when they're doing this, let me back up a couple steps, is instead of contouring the surface, they end up contouring all of the lines that they created. So let me select these lines like that. So my lines are selected. You go back into contour. Like that, same 100 feet. And they end up with a bunch of points. I don't want a bunch of points. I want curves. So if you contour a mesh or a surface, you'll get a line. If you contour a line, you'll get a point. So I don't want that, so I'm going to delete that. Takes a second because there's a lot of them. And I'll come back and I'll do that contour again. The other thing, my contours were actually probably slightly narrower than I needed them to be. Remember that this is divided up into a bunch of triangles. I really only need one contour at each interval of triangle because I can't get more accurate than that. So that's how I'm determining what this is. 100 feet seems reasonable for what I'm doing. 50 feet wouldn't be close enough. We'd be losing information. So let me repeat this one more time. I'm going to go up to Curve, Curve from Objects, Contour. Select Objects for Contours. It's going to be my surface or my mesh here. I'll press Enter. My base point is right there at the corner. I'm going to go off in the Y direction here. Sorry, that direction. Distance between is 100 feet. And there we go. So at this point, I can turn off the SketchUp altogether. And I should see in both views here, in the front view and in this view, perfectly vertical lines. Yeah?
So when determining the distance in between your two lines, like you said 100 feet, can't you snap to anywhere on that mesh and just get the distance between those two triangles?
I could. Okay. I could go from vertex to vertex and do it that way. Yeah. What we're creating doesn't have to be perfect. We're looking for ballpark. If I had done it at 50, you would see that that's not too much. I went a little bit over doing it at 100. It's not the end of the world. If I did it at every 50 feet would be closer together. If I did it at every 200 feet, it would be too far apart. Sometimes you'll end up with just too many curves to do the curve network at the end. So if I did it every 10 feet, for example, it's far closer than I need, and my mesh would be just too tight. So we're just kind of looking for a happy medium. But yes, you absolutely could do it by snapping to distance and doing it that way. So now that I have all of my contours, I'm going to look at them in the top view. And when I look straight down in the top view here, I should see basically a perfect grid. I shouldn't see anything on angles. I shouldn't see any diagonals. It should be a perfect grid. But in order for the contour to work, I need to clean up the edges because I've got some ragged edges here. And I've got some contours that don't actually make it all the way to the corner. That's because of the difference between true north and north. So I'm going to go ahead and do some trim work. I'll select the curve that is far enough in. Go maybe there, there. I'll make my life easy and pick that one. And I'll pick that one as well. With those selected, I'll go in and use the trim command. So I can click on the trim tool. I can go to edit trim or type trim. And then select objects to trim. I'm going to click and drag a box through all of those objects. I'll do the same thing through all of those objects. I'll do the same thing through all of those objects. Oops, looks like I missed that one there. And the last one would be through all of those objects. And so by doing that trim, I end up tidying up the outside border of my objects. So I've got one line that goes all the way around the outside. The alternative to that would be to create a curve that goes point to point all the way along the outside. But to me, that's way too much work. I'd rather trim off a little bit. It's faster to do it that way. And this is so much terrain information that it really doesn't matter. So now that I have that all trimmed up, we could look at it in the perspective view here. And essentially, it's ready to create an actual NURBS surface, a real smooth surface. But before I do that, this is a great place to save your work, just in case Rhino decides to crash on you. So I'm building that into the lecture. I'm reminding you right at this point, because now would be the time to save. I'll go to File and then Save. And I'll put it into today's lecture. So this was Mount Diablo. I'll click Save, and there we go. Yeah?
When I look at the 4 different views, it's not showing up in the top or the right.
Zoom out or select it in the view where you can see it, and then type Z, enter, S for selected, enter.
What was that again?
Z for zoom, enter, and then S for selected, and then enter. So, for example, if I wasn't seeing it here, like that, if I select it in the view where I can see it, move back to this view, Z for zoom, S for selected, it'll bring it into my view. So now it's time to actually create the curve network. But before I do that, I'm going to create a new layer here. So for the interest of clarity, I'm going to call this curve network or network surface. Again, I'm just trying to be clear for you guys. I'll double click on curve network. There it is. I will then initiate the curve network command. We just did this last class. So I'll come to surface, and I'll go to curve network, select curves in network. I'll go ahead and select all of these curves like that, and I'll press enter. This loves to pop up saying you have more than 100 curves. Are you sure you want to continue? Yeah, I do. So we'll go ahead and continue. If it recognizes it correctly, we will end up getting the A, B, C, and D. That's where we're after. That's what we want to have happen. Typically, the places where people screw up at this stage is they have an extra curve. So for example, copy, in place, and then they go in and they do the curve network. Yes, go ahead. And Rhino says, wait, I can't figure it out. Select the first curve in the first direction. That's a bad sign. You don't want to go through and manually click all of these curves. It would actually solve the problem, but it's way too much work to do it that way. So we don't want to do that. So if you end up in that boat, chances are you had a problem during the contour command. It's probably easiest to just do the contour command again than to try to figure out which curve is bad. The other thing that can happen, sometimes it'll say there's problem curves. Would you like me to highlight them? And it'll highlight a couple curves in the middle saying there's something wrong with them. I don't necessarily know what's wrong with them. Usually if that happens, if you press the delete key and then do the curve network again, you'll be able to do the curve network. It happens sometimes. In my case, it worked out just fine. So I'll go ahead and select all of them. I'm going back to curve network again. Surface curve network. Or I could type in network SRF. And it builds those. I'm seeing the 4 sides. The rest of this is all fine. I'll go ahead and say OK. Now this process does take a little bit of time. So we need to let Rhino do its thing. Have a drink, you know, that kind of thing. Yeah?
If our internet isn't working, should we do a network reset or just let it come back?
Just restart the computer and see if that fixes it. Anybody else having network problems with the internet? It's going in and out. OK. So something's up with the campus then, which makes it really annoying. Don't close, actually, before you do restarts. If you already have Rhino open, leave Rhino open and use the sample file if you can use it that way. Because if you close Rhino and the network goes down, you can't get Rhino back because of the way the license server works. So it might be better off to just kind of wing it that way. Okay, so it just finished up. It does take a little bit of time. I actually paused the recording there for a little bit so you didn't have to wait. When you finish your curved network, Rhino will suddenly get very, very heavy. Like if I tried to zoom in right now on this, I'd move the scroll wheel and wait like 10 seconds, and then it's going to move because our surface is really, really dense. So what I'll do is I'm going to click off the surface for a second so that nothing's selected, and notice that it takes time to update in each of the views. And what I need to do is select just the surface. So if I click once, I should get just the surface this time. It will turn solid yellow. That's the density of the surface. Then I wait, and I'm patient. Then I will type rebuild or go up to the edit command and choose rebuild. And when I choose this rebuild command, again, patience is a good thing. There we go. I'm going to adjust the point count for the rebuild. So in this scenario, it's probably going to be somewhere between 50 and 200 would be my guess in terms of the number of points. I'm going to set this one right now at 200, and I'm going to show you the difference later on. I'll do several rebuilds. So I'm going to do 200 by 200. Like that. When I'm done, I'll go ahead and say OK. And it's going to rebuild the surface. As soon as I do that, Rhino will come back and it'll be easy to work with again. So at this point, let me turn off the contour X and the contour Y, and this is my resulting surface. So it's now a NURBS surface. It's a mathematically defined Rhino surface as opposed to a triangulated mesh. And if we look carefully along that ridge, for example, you can see the artifacts of the triangulated mesh. Likewise, coming up this valley, we can still see the artifacts of that triangulated mesh. I'd like to be able to smooth those out just a little bit more. And actually, if you zoom back far enough, you can kind of see the triangles or the little squares that are left. So this one was at 200. I'm going to copy this onto several layers just so you can see the difference. You don't have to do this part of it, but it will help you to see the difference. So let me go ahead and I'm going to create a new layer. I'm going to call this one 200. Okay, so all I did was I copied these. It's the same surface. I just copied it on multiple layers so you can see how the rebuild is going to change this surface. So this was at 200 by 200. And so we'll keep that one alive. I'm going to move to my layer that is 150. I'll turn off the 200. And I'm going to rebuild this surface at 150 by 150. If you didn't have a square, you would probably want to do it in different proportions. Mine is a square, so doing 150 by 150 makes sense. So now that I've done it at 150 by 150, we can look at the ridges again, and we can look at the valleys, and we can see that, yeah, they're still triangulated. There's still little bumps to them. But if I compare it to if I put these two on top of each other, actually, let me change the color of this 200 so you can see the contrast there. You can see that the 150 has smoothed it out just a little bit more. The red areas here are sticking up, and so you can kind of see them on top of each other. So if I were to turn off the 200 again, and let me jump down to the 100, I'm going to turn off the 150. I'm going to rebuild this one at 100 by 100. And I'll say OK. If I look at those ridges, they're much smoother. If I turned on my 200 again, and we saw the contrast, we could see that, yeah, it's really starting to smooth it out. And sometimes when you see these off on top of each other, you can start to see how much it's smoothing. So at that stage, I'm retaining most of the terrain information, but it's smooth enough to where, okay, it's starting to kind of even out and be nice. Let me turn off the 100. I'm going to turn on the 50 layer, and we'll rebuild this one at 50 by 50. I'll say OK. And now as I look at this one, it's almost perfectly smooth. And so I have most of my terrain still, most of the valleys and everything, but I'm really starting to lose some of the detail. So the smoothness is getting to the point where, you know, this, my ridge here in gray, I'm losing a lot of the definition on that ridge. It's starting to even out just a little bit more. And so that may be borderline too much smoothing. And you have to kind of decide where's that happy medium point. Let me turn off the 200 again. I'll move to the 10. And I'm going to rebuild the 10 to 10 by 10. Well, no surprise, this got really smooth. There's no triangular artifacts whatsoever. It's nice and smooth. But I've also lost a fair amount of detail in this surface. So it's simplified by a lot. If I were to turn on the 200 to see in contrast, yeah, there's kind of big swatches that have dramatically changed. Like this ridge line, for example, got a lot lower because I smoothed it out. So there's always a point on your terrain where there's too much smoothing and there's not enough smoothing. So in my scenario, maybe the 100, maybe the 50, maybe I do one at 75. Let me leave that one on. Yeah, that's probably the right happy medium. I'm keeping enough of the valleys. I'm reasonably happy. So sometimes it takes a couple rebuilds to kind of decide. My guess is that 100 or 75, 80, somewhere in there is going to be about right for what you want. So I now have this nice piece of terrain that is a Rhino model. I can then manipulate this surface as I would any Rhino model. We're going to do a couple more things with this before you're done for the day. And of course, this will come back. We'll repeat all these steps again in a slightly more organized fashion next class. I'm going to go ahead and slice up this terrain as a bunch of topo lines. So instead of doing my contour in the X or in the Y, which I've done, I'm going to do a contour in the Z to slice it up like it would be a topo map. So let me go ahead and create a new layer, and I'll call this topo lines. I'll make that the active layer. And I'm going to use that contour command again. So I'll go up to curve, curve from objects, contour. The object is going to be this smooth surface. I'll press enter. Contour base point is going to be, it doesn't really matter, it's just one of the corners. I'll use that corner there. And my direction perpendicular to the contour planes isn't the X, isn't the Y, it's going to be in the Z. I can't get to the Z from this view. So I will go into one of the side views and I'll go straight up. In this scenario, it's the front view. It doesn't matter which view it is, as long as it's going straight up and down. I'll do that. Then it says distance between the contours. This is where I'm going to choose what the distance should be. A typical like U.S. Geological Survey map is at 40 feet. So for today's purposes, I'm going to pick 40 feet as an arbitrary value. We will get to how you specify what this value is. That's coming next class. But for right now, I'm just going to pick 40 feet. And you'll see Rhino actually build all of those contour lines as you go through. And so what it's doing is every 40 feet, it draws another line. That then represents a topo map of this particular piece of terrain. Now, if I wanted to work with that topo map, it's in 3 dimensions right now. So I could take this one step further if I wanted to manipulate it. We'll do another new layer. And I'm going to call this one topo flat. And on that topo flat layer, I will draw a rectangle, a rectangular surface, a rectangular plane, larger than all those topo lines. I will switch my view into the top view, and I'm going to use the project command to project them onto that surface. So I'll deselect everything. I'll use curve, curve from objects, project. Select curves and points to project. I'll select my curves. I'll hit enter. Select surface to project onto. That's the surface. I'll press enter. And it then gives me a flat, two-dimensional map of what my contours are. So I've worked full circle. I started with the terrain, and I ended up with a flat contour. So I can then move this out, just so you can see it a little bit better, like that. Let me turn off my surface. Let me delete this plane, and you can see these next to each other. So there is my three-dimensional set of contours, or set of topo lines. And here is my flat set of topo lines. At this point, I could take this flat set, and I could export an AutoCAD file from it, and then bring it into AutoCAD or Illustrator or whatever we wanted to do. So that would be File, Export Selected, and I would change this to AutoCAD Drawing. Let me go ahead and save it on my flash drive. This was Mount Diablo. And I'm going to add the 40 feet just so that I know this was the 40-foot contours. So that then, the default options here are fine, or I could use the 2004 polylines. It just keeps everything joined together nicely, so we'll go ahead and use that. And that then exports that to AutoCAD. So this is like a baby version of what we're doing over the next couple classes. So it's a lot of the same steps, but there'll be more technical information about why you pick a certain contour and how you do the projection and why you do it a certain way, etc. So for today's purposes, I want you to go through and be able to do this. I want you to be able to bring in your terrain from SketchUp, be able to create the surface using the contour command and then the network surface command. Ultimately, cut these topo lines out using the contour command again. When you're all done, I ask you guys to design a meditation pavilion. I decided that I didn't want you to do that anymore. Instead, you get free time to work on your assignment, which I think is far more valuable. What I'm going to ask that you do when you post for today is I want some kind of a screen capture of these lines or this surface, something like this. So in this scenario, I have the three-dimensional one. I have the flat one. I'm zooming in so I can see them both about like that. I'll go to the little triangle in my perspective view, and I'll go to Capture to File. That's going to give me a JPEG of this. That's all I really want to see. You don't have to upload the AutoCAD. Even if I say upload the AutoCAD, you don't have to. So let me go into my live demonstrations for today. And there it is. I'll call this Mount Diablo. I'll click Save. And that then gives me the JPEG. I will post this and then use the rest of my time to work on my table and chair. Remember, the table and chair is due before I start talking on Monday. So if you turn it in or you upload it after I start talking, it's late, subject to the late penalty. So make sure you turn it in before. Make sure you turn it in, period. The worst thing you can do is not turn it in. So please do that. I think that's the best use of your time afterward. And so don't waste your time. It's a good chance to make your table and chair a little bit better after you get through this. Are there any questions? I know it's a lot to take in, but again, I'm going to repeat this whole thing multiple times going in the next couple days. All right?